Carpe Diem VPN. Seize the network.
Hey everyone, welcome back. And in this video we're going to provision our fabric with DNA Center. Last time we did LAN Automation, we brought up an entire underlay, we have a managed network now, and now we're going to start assigning fabric roles, pushing fabric config, and just getting our SDA Fabric up and running. So let's look at that real quick. Here's our topology again. This should be familiar if you've watched the other videos about this lab. In this SDA Fabric, we're going to use Cheese 6 and Cheese 7 as our control plane nodes. What that means is that they're going to be running a Lisp, they're going to be performing the function, should I say, of the Lisp map servers and keeping the map cache database. So when an edge node registers an endpoint, they're going to register with the control plane nodes. And when they query for a destination, they're going to query using Lisp to those control plane nodes. So they're going to have that config. And once we start pushing the fabric roles, we can actually go into those boxes and look and see what DNA Center pushed as far as that configuration. In this particular lab, the Cheese 6 and 7 are also going to perform the function of our border nodes. Our border nodes, again, are the part of the fabric that have appearing adjacency with devices that are not part of the fabric. And we have different kinds of borders that we can run. So we can run an internal border and external border, or kind of a fusion of the two. And what that actually boils down to is whether or not we're going to import routes from outside the fabric into the Lisp map database, or if we're just going to bring in a default. It all has to do with how devices within the fabric are going to try to look up, how do I leave the fabric, or is our destination part of the fabric or not. We're going to use an external border, so we're actually going to configure the border nodes to not to import all of the routes from outside the fabric, but just to import a default route, so that when our edge nodes look up a route that isn't part of the Lisp database, the Lisp map server database will point them at the border nodes, which in this case are the same node, and then out to the rest of the network. Let's see. We're also going to have our edge nodes. Now our edge nodes, again, are our user-facing or device-facing nodes. So they're going to have the Anycast gateway for the virtual network configured on it. They're also going to have the .1x type of configuration. If we're using ICE for enforcement, this is going to be where our scalable group ACLs are downloaded, and they're network access devices in ICE. The last thing is Cheese 6 and 7 are pulling triple duty. We're going to actually configure them as an overlay multicast RP, an Anycast RP, using MSDP. This is necessary if you want an overlay virtual network. So for example, your corporate users VRF or something like that, to be able to receive multicast feeds. So last time we configured multicast in the underlay. That's to support underlay activity. I don't want to get too far into that, but here we're going to configure multicast in the overlay so that we can provide RP services for overlay devices that want to receive multicast. Now when we talk about fusion routing, which is what our borders have to be configured to do, there are a couple schools of thought about how we can do this. One is that we will, and this will make more sense once we actually get to the screen where we start configuring border handoff, but I just want to cover it now. One school of thought is that we can take DNA Center, we can check all the boxes for all the virtual networks, all the VRF peerings we want to do. We give it a block of IP addresses to configure the border handoff IP addressing, kind of like we did with LAN Automation, and then we push the button and DNA Center figures it all out. It allocates VLAN interfaces if it's a switch, or allocates sub interfaces if it's a router. In this case it's a switch, so we're going to get VLAN interfaces. It ties each VRF to a VLAN interface, gives it IP addressing, and builds the BGP config to peer outside of the fabric. So we can configure all of that at once. We can push the button. We can let DNA Center allocate it however it likes. build a config, and then we can go to these devices, Cheese 6 and 7. We can take the config that DNA Center pushed, we mirror it, or we'll change the IPs, change the peerings, change all the interfaces, and we can go put that on the Fusion router so that all the peering will come up. The IP addressing will be the same, or rather will be within the same subnet. The VRFs, the BGP neighbors, everything will match if we take the config off of Cheese 6 and 7 and mirror it and put it on Charlie 16 and 17. And then all the BGP peers will come up. That's one way to do it. The other way to do it is to realize that DNA Center is a controller and it's predictable. So DNA Center will automatically allocate certain VLANs or sub-interfaces for this function, for the border handoff function. And based on the IP addressing that we give it to use for the border handoff function and how we start allocating the physical interfaces that we're going to build config on, and also the per VN, so per VRF, how we're going to do it. If we do it in a certain order on certain interfaces, we can actually be deterministic about how the config will spit out. So as an example, here we've pre-configured Charlie 16 and 17 because we're going to apply our border handoff config in such a way that DNA Center will be predictable in how it will do for each VN and for each VLAN interface. So as an example, if we build, if we deploy a border handoff for the infra VN or the global routing table, and we do that first, then we know that it's going to choose VLAN 3000 and it's going to choose the first, it does /30s, so it's going to choose the first IP in the subnet to put on that VLAN interface. And if we let DNA Center run through the deployment, it's going to push that config to the device, and that device then will have that config. Versus if we check all the boxes at once, then DNA Center figures out, okay, well, this VN gets this VLAN, this VN gets this VLAN. It's not predictable. So in our lab, how we did it was we knew how DNA Center would configure the devices based on us doing it in a certain order, a certain way. And so we pre-built the config on Charlie 16 and 17 so it would just come up. So as we add VNs, DNA Center, we're going to push the config so that DNA Center finishes configuring that VN on that interface, and then that's how that's going to work. So you're going to see that. I'll speed that part up because it can be a little bit tedious, but again, Fusion routing isn't 100% automated yet, so we have to kind of pick our battle. Either we mirror the config and go edit the config and splat it onto 16 and 17, or we do it this way and we let DNA Center do it deterministically, and that means we have to click through a few more times instead of doing it all at once. So let's go ahead and go over to DNA Center and do that now. Okay, here we are back in DNA Center, and before we started this process, I wanted to cover something I just kind of brushed on last time. These are our IP address pools. So they have to be configured at the global level within DNA Center. You'll see we have our full DNA Center hierarchy here. We configure our IP address pools at the global level, and so we can use supernetting here. You can see in this lab I didn't use a lot of that, but we can use supernetting here. And then when we're ready to actually assign an IP pool to a site, for example, if we're going to use certain campus VN within a certain site or something like that, or an AP pool. This is an AP infra pool. So you can see here we gave it a class C for APs to actually get their management IPs and then join the WLC. We can start reserving subsets of this within each site. So let's see if I can show a case where we did this. So in this case it matched. You can see we just took the whole AP infra pool because we're again only doing one site. But you can see if we had a supernet here, say 192.168.100, and did /22 or gave it 4 class Cs, we could carve it up between sites and reserve them between sites. And then when we go to build our fabric and our virtual networks, we could allocate those IP pools based on what site they're at. You can see in this case we inherited, on the right here, you can see where we actually just inherited our AP pool from the home campus level. So we didn't do anything crazy here. This was easy. So I'll just show you how reserve looks. You would create an IP address pool, name. I wouldn't worry about too much about the type. We usually just use LAN. There is some reason that you would use other ones, but I'm not going to get into that. You can see here's our IP pool. Here's our supernet we're going to pull from. And what's the CIDR prefix that we're using at the site? Or we could use number of IP addresses and let it figure out. And then where's the start of the subnet that we're pulling from, that we're going to grab. And so if we were going to use this for users or devices, we would say, okay, well, within this site, what is the gateway address? And that's what it's going to use to configure the anycast gateway. And then what's my DHCP server? If we're expecting a DHCP server, this would add the helper address config. And then DNS server, that's not for the helper address, that's just DNS servers for that scope. Go ahead and cancel this. So that's how the IP addresses pools work. Now let's go over to provision, and we'll start building this fabric. So here's all our devices. We're going to start building a fabric. So go over to fabric, we're going to add a fabric, and we're going to give it a name. We're going to call it home office. And we have to say, what is the site hierarchy of this particular fabric? Because we can run multiple fabrics. You know, there could be a design where we're geographically distant and we have, you know, multiple fabrics that we're going to run. We're going to run a fabric at one site and then have some kind of transit in the middle, a WAN or something, and then run a fabric at another site. So we can have multiple fabrics. In our case, we're just going to add the whole thing. It's just the home office is going to be a fabric. And then which virtual networks are we going to run within this particular fabric? So we're going to run a corporate users VN, a guest VN, and one for security devices like IoT devices. The default VN is a holdover. You can't actually get rid of it. It doesn't do anything though. I assume that might go away in a future release. Infra VN is the global routing table. It's our underlay. So usually we only use that for underlay connected devices. For example, our wireless access points would use this as their management IP addressing, or rather IP subnet, to go join the controller. And then of course the broadcast SSIDs that they use would be the overlay, or the corporate or guest or security, whatever wireless networks. So we're going to go ahead and click add here. We're just going to we're going to put all our VNs in our fabric. And I think I may need to do one more thing. And let me go back here. Before I start, I forgot to do this earlier. I'm just picking this up in the morning. So I forgot to do this last night. So I didn't mention it before, but there's a thing here called device role. The device role doesn't actually make any config difference, but what it actually means is that on the map for our fabric, so where you're going to see it, I'm going to come back to it, but the fabric has like a map, a diagram of the devices in your network, and you're going to place them all, and it tries to figure out how to build the map. Well, first of all, physically it does it via knowing how devices are connected, but it tries to put them in a hierarchical fashion based on what we've flagged as the device role. So you can see here, obviously we don't have 6 different core devices. DNA centers try to figure out what they are, and so what we're going to do is just quickly look. And I have a mapping of the serial number to the device, so I can pick. So I know which devices these are, because, like I said before, I didn't build a CSV that mapped the serial numbers to the name that I wanted them to get. So now I'm kind of suffering for having not done that. So I need to click on the device, look at the serial number. I have a cheat sheet that tells me which device is which. So these actually are devices that are distros. This is CDR, choose 11, that's a distro. So we're going to change that from core to distribution. And then this device, that's actually an access device. So we're going to change that to access. And then for this device, okay, that's also an access device. And then lastly, I think this is the last one, N6. Yes, this is also an access device. Access device. Oh, sorry, I had a couple left. This is a distro device. And then this last one should be access. Yep, it is. So we should have 4 distros, which we do, 2 cores, which we do, and 4 access. So we do. So sorry for that brief detour, but just this will make sense in a second when I get back to the fabric. So when I get into the fabric, based on the hierarchy of the site, it's going to pull in the devices for that. So here you can see it tiered them based on the role that we assigned. That's what I was talking about. So let's take a look. So here's cheese 6 and 7, and you can drag these around and notice that the connectivity is based on what DNA Center sees as the connection points here. So we can drag these out or however we want to do it. There we go, and here's our devices, and there's our 2 buildings and our access switches. So this is the fabric infrastructure. What we're going to do now is we're going to start adding, hold on a second. Yeah, we're going to start adding roles. Okay, and so this is cheese 6. Now, remember what we said it was going to be. We said it was going to be a control plane node, but it's also going to be a border node. And when we say border node, we immediately have to do some configuration on the handoff. What does the handoff look like? What is our local autonomous number? It's 65020. We don't have to do a full config here, so I'm actually going to come back to this. But when you create a border node, this checkbox has to do with whether it's going to be an internal border or an external border or a fusion of the two. So in this case, we want it to be an external border, so we're going to say default. We're going to send a default to all of our virtual networks. That's going to flag it. It's going to bring it into Lisp and make this border node. Basically, it's going to make it, if you know Lisp, it's going to make it a proxy ITR and ETR. But it's going to inject that default route so that if a route lookup in Lisp doesn't find it, the control plane node will say, oh, well, this guy here, this border node, knows how to get to stuff that's not part of the fabric. It's unknown to Lisp, so send it there. And then we're going to check this box because we don't want to import all of our external routes into the Lisp map cache. There's not really much point to doing that when we're already bringing in a default route. So this has to do with, we haven't set up a transit or peer network. We'll do that next. But we do need to check these boxes because once we hit the add button and save it, we can't come back and change the border type without reprovisioning the device as like removing the fabric role and then re-adding it. So we check these boxes and we'll come back to fill in the rest of this in a little bit. So that's our border handoff information. We've made this a control plane node. The last thing we're going to do is we're going to check the box to configure this as a rendezvous point. In our lab, we're only going to provide multicast for the corporate users VN, and you'll see I created an IP address pool just for multicast. And what this is going to be used for, this IP pool is used for configuring the overlay RP, which is going to be the loopbacks on both of our devices that we configure for being multicast RPs, and the MSDP loopbacks on which they're going to peer. So if you don't understand multicast very well, I do a breakout for Cisco Live where I talk in depth about Anycast RP, and that's what this ends up being. So you can take a look at that. All right, so we're going to give it that, and we're going to say for what virtual networks do I want to supply RP or multicast services. I'm going to say corporate users VN because that's the one that's tied to the checkbox that I just, or the VN I just enabled it for. So we're going to push config that's going to create a border node config. We're going to push config that's going to make it a control plane node, give it all the Lisp map cache information, and we're going to configure MSDP. And we're going to push that. And so I'm going to click add, but I'm not ready to do it just yet because I want to do it over here as well. So we're going to do this, we're going to make this a control plane node. We're going to make this a border node also, 65020. Again, we're going to make this an external border. I'm going to come back and fill out the rest of this in a little bit when I do border handoff, but I'm not ready yet because I haven't configured the transit network yet. So, and last, we're going to configure this. See, we're picking for this VN, and notice now I can't choose a different multicast IP pool. I'm locked in because it wouldn't make any sense to choose a completely different IP addressing schema when we're going to set up Anycast RP with MSDP. They need to share that information. So again, we're going to check the box for corp users VN. We're going to click enable. So that's 3 roles that we're going to give these devices. I'm going to click add. And I could do my edge nodes now, but I'd like to get this config pushed out, and I can come back and do the edge nodes. So I'm just going to click save. There's no really reason to do it. I just want to show you guys what happens from DNA Center when we push that information, what that config is going to look like. So I'm going to click apply, and DNA Center now receives the intent. All those button clicks turned into configuration. So we can log in. I've probably timed out of one of these potentially. Okay, so let's log into Cheese 6 and let me bring it over. And okay, let me bring that over here. Try to make that bigger. Okay, so DNA Center should have pushed at this point, started pushing a config. So let's see if it started, see if it did it. All right, so look, when we made this a control plane node, we got all of this config. And I'm not going to go through the whole list of config. The point I'm making is that there's no magic here. DNA Center is not a black box. We told it we want it to be a control plane node. DNA Center understands what config is involved in making this box a control plane node. We're going to make it a map server. We're going to make it a map resolver. We're going to add, the instance IDs and stuff, so on and so forth. This one, for the corp VRF, we're adding that instance ID as an example. There's a lot of, and this is support multicast overlay, by the way. As we add edge nodes and add extra virtual networks, we'll get more Lisp config here. But I wanted to show you that that's what DNA Center is doing on the back end. It's logging into the device. It's pushing this config based on what we told it. So see that our map server, map resolver 6 and 7, that's because we told DNA Center we wanted 2 control plane nodes. These are the loopbacks, by the way, for the Cheese 6 and 7. So we also said we wanted it to be a rendezvous point and a border node. So we should get some MSDP config, and we did. We're saying my peer is the other one. We're going to use loopback as the connect source. And then, here, based on the fact that we said we wanted to run multicast in the corp users VRF, we're setting up an overlay multicast MSDP here on that VRF. No surprises, no black box here. And then lastly, let's take a look at the BGP config. I think it hasn't really configured much yet. This was our VLAN 100-101 in the last video when we did LAN Automation. We had set up the BGP peer for reachability. This is not pushed by DNA Center. None of this part was pushed by DNA Center. Just that we have a BGP config. So you can see we did add an IPv4 VRF corp users VN so that we can advertise the RP, the overlay RP. So that's about all that's been added right now from DNA Center as part of a border node config. And that's because we haven't set up the transit network. We haven't set up I left all that config blank, if you remember, when I added the role. So let's minimize this. Let's go ahead and we can start adding our edge nodes. So let's do that. And when we add edge node, we just say edge node. There's no extra config we need to provide. We just tell it we want it to perform the function of an edge node. You'll see where we add the VNs and the IP pools for each VN in another step, a little bit further down the line. So I'm going to go ahead and save that. And actually, let me log into one of these boxes so we can see what that looks like. We'll leave that one alone. Let's open up a new session. Oh. Okay. Okay. Bring that over, make that a little bit bigger so we can read it. Okay. Apply. All right, so make this a little bit bigger. So let's go to the cheese rack. is our terminal server. And let's go to cheese 14. 14 is this guy down here, I believe. So again, we had our DNA Center pushed our credentials. So we have to log in. And now let's just watch this guy. And if you remember from my last video, or if you saw my last video, there's a pretty basic config on this device now. It's just ISIS and routing for the physical interfaces. There's no other config here yet, minus I think there's ICE config now. We provisioned the device, which pushed down AAA config for ICE for host onboarding, although we're not doing it right now. So, and we have an access point that's connected that keeps rebooting. It's looking for a wireless LAN controller. So very little config right now. Let me see if I can. So let's see if there's any Lisp config. There won't be any actual Lisp config really. This is on the physical uplinks for the underlay. So there's no Lisp config. You'll see there's no VRFs. The management VRF, of course, is the out of the box one. There's no VRFs on it, so there's no VNs configured. This is just a switch, not doing anything. So let's go ahead and save and deploy our edge node configuration. And keep that box open. Oh, wrong box. Keep that box open. And you can see we're logging in. DNA Center's logging in. It's going to be making config changes, delivering that programmatic config. And now we should have some edge node config. We still won't have our VRFs, but you can see we've got Lisp coming up. We've configured PIM on the interfaces because we said we wanted to run multicast. So that's it basically. That's what we're doing. So once this cleans up a little bit, we'll take a look at that config. Okay, so show run section Lisp. So we told this box we want it to participate in the Lisp process because it's an edge node. So notice that the map resolver is set to cheese 6 and 7. The map server is set to cheese 6 and 7. This SGT thing means we're carrying SGTs as part of Lisp. Again, that's it. That's the config we pushed. We told it we want to participate in Lisp. We're an edge node. We're providing services. That's it. Again, we don't currently have more than the corp user VRN, and that's just the VRF, and that's just because we're setting up overlay multicast for it. So the users themselves are not part of this picture yet. So at this point, we have a very basic fabric, but no users, and we don't have any border. So let me add the VNs, and then we'll go back and do the border config. Let's see, we're almost at 30 minutes here. So I'll do one border config so you can see how it works, and then we'll just call it there. But from a host onboarding perspective, we have to go to host onboarding. Now we do several things in host onboarding. We say what kind of authentication are we going to use? What's the normal authentication? We're going to use closed authentication.1x. Save it. We push it. It's going to log into all of our edge nodes and change the default.1x or the default authentication policy to closed authentication. That's the config it's going to add. Now here you see we have multiple VNs, and these VNs we chose when we created the fabric. When we said I'm going to make a fabric, what VNs am I going to carry? These are the VNs. Now, and you can see also that the M on corporate users VN means that we're running multicast, overlay multicast in that VN. So now we need to say, what is the IP pool or pools? We're going to create the VRF. What are the IP addresses that we're going to use? We're going to create a corp user. Notice that I'm using a full /16 for my overlay. Now, I mentioned it in the first video why we can do this, because it's not one big broadcast domain, and it simplifies our IP addressing. We're going to use Anycast gateway on all of our edge nodes, so all of our edge nodes will carry this. So here's the name it's going to deploy. You can change this. This is the actual physical name of the VLAN and VRF. Groups, if you don't have ICE, or if you want to set a default basically tag, you can do that here with scalable group tagging. You can tell it, anybody who connects to this VRF is going to carry this SGT. We're going to do wireless with corp users. So we're going to have an SSID that drops people onto the corp users VN. So we check wireless pool so that we can, when we do fabric wireless, we can choose this pool and tie it to the SSID. Our traffic Generally, we're going to choose data. I don't remember exactly what voice does. It might be better treatment, or it might be something we use later when we do QoS. We're not using this as a layer 2 flooding. You can, if you need a broadcast network for some reason, you could do that, and then it'll use a underlay multicast to carry that bum traffic, the broadcast, unknown unicast, and multicast traffic on the underlay. We're not doing that with this. This is just a normal user VN, so we're going to update that. And here we've now tied the VN itself to what is the IP pool that we're going to use for the VN. And we're going to do that for everything except for the default VN. So I'm going to add the guest users here. And again, we're just going to say data. We're going to have a guest wireless, so we'll check for a wireless pool. So we can tie that IP pool to a guest wireless. Our infra VN is another way to say that is global routing table or underlay. So this is only going to show ones that are eligible, basically. So we're going to use AP infra pool. And here you can see that the pool type actually has AP. So it expects that. So in the underlay, it expects that APs are going to connect and they're going to need management. And so DNA Center recognizes that and says, okay, so you've created an IP pool that we're going to use specifically for AP. So there's going to be some extra config there that's going to go into making sure that that's used for an AP pool. And then we're going to close that. And then for security devices, this is like our IoT cameras, security badge readers. We're putting those in. We're doing macro segmentation here. We're putting it in an entirely different virtual network so that normal users won't get to it. We could have put it in the corp user VN and applied an SGT and then said like SGT security devices, and then used SG ACLs to segment users from talking to those devices. But there's still good network design reasons to do macro segmentation or to segment parts of the network at a higher scale. For example, we still might want to inspect that traffic, send it through a firewall, and not have to get crazy with our rules. So there's still a good reason for macro segmentation in the network. Obviously, we're not using a wireless pool for this. We're not going to do layer 2 flooding. Maybe if the security devices needed that, if it was like a manufacturing line or something, we might do that. But we're not going to do that here. All right, so we're done. Every virtual network we're going to carry in this fabric now has an IP pool. We'll come back and do the wireless stuff later. I want to cover this, but we're not going to show it because we're almost out of time. This is where we can statically, if we didn't have .1x, we could statically say this port will always get this tag. So these ports are down, obviously, but let me show you. We could say this device is, say, a server. Well, server's a bad example, actually. Let me say like a user device. And then what IP pool should anybody connect to this port should automatically be placed in this VN. So we could say it's a corp user VN. They should get this scalable group tag, and not a voice pool in this case. And then what kind of authentication should we use? So if you had an IoT device that doesn't do .1x, you wanted to put it in a certain VRF, so like say a security device, you want to say no authentication. So that's going to hard set this box, this port. It's going to push, when I click save, it's going to push config to that port on that switch, and we're going to statically assign all of that. No, I'm not going to do that, so I'm going to go ahead and clear it. But that's how host onboarding with port assignments works. Okay, so did I fail to click the, okay, no, it's good. So there we go. And again, I'm not going to do wireless as part of this. So now back to fabric infrastructure. I'm going to show you how to do one border handoff and the transit, and then we'll be done. Because it's just, the video is getting a little long. So here, we're going to go back to all fabrics. I'm going to create a transit network. The transit network is our off fabric. What does our off fabric network look like? Now, if it's an SD access transit, that means that we're expecting that our off fabric device can carry scalable group tags. And if it's IP based, it's just normal handoff. There's no SGT happening. So let's just call this border. We're going to use BGP as the routing protocol. This is for the neighbor. What is the neighbor's AS number? Save that. Okay, so that just allows us to go back to home office and then go to our border node. So now we're going to add that border config. And we're going to say first of all, I created an IP pool that I wanted to carve up into /30s for border handoffs. So DNA Center is going to take this /24, just like with LAN Automation, it's going to carve it up into /30s for each peer, for each VRF. So I'm going to say that. Use this IP pool, carve it up as you see fit. Transit peer network, see now we can choose IP border. We're going to click add. And then border, here's the magic happens. We're going to say, what is the physical interface attached to the border that I'm going to use? So in this case, it's 105. And this is where I was mentioning, if you check all the boxes for each virtual network, DNA Center will figure it out, it'll allocate it, it'll be a mess, it will not be it won't be deterministic. So we're going to do it in a certain way that we know we want to do it, so that the BGP peering will come up on the other side. So I'm going to check infra VN, and rather than check all the other boxes, which I will get to, I'm going to click save. And so I know which interface I'm going to build the peering on, and I know what IP addressing and VLAN interface is going to get assigned to that. So I can click add, and save, and DNA Center is going to go apply this config. Let's go back to Cheese 6. This is Cheese 6, right? Okay. So what should happen is that DNA Center will log in, it'll configure interface the VLAN. Oh, that's interesting. 3017. Oh, this is because okay, so this is because I must not have cleaned something up when I built this fabric last time. This is my fault. So what should have happened is that it should have built, say, VLAN 3000, and then of course on the other side our BGP would come up because the Fusion router is configured with the VLAN 3000 and with the IP address. So let's take a look at what went wrong here. So yeah, so you can see that I failed to clean something up the last time I built this lab, so that's my fault. It should have reset everything back to the IP pool, and the VLAN interfaces should have been reset. So that's my mistake. I hate to end the video on a mistake like that, but what should have happened is it should have done VLAN 3000, taken the first IP out of the pool, and then you would see the BGP peering automatically come up. So let's take a look and see what else got configured. So you can see, now we did this for the infra VN. So this will be under address family IPv4. You'll see we're aggregating our AP pool, and you can see we added a neighbor config here. This is the config added by, well, this is the config added by DNA Center. And if it were the same on the other side, the Fusion router, it just would have come up. So my mistake for not clearing out some of the stuff when I rebuilt the lab. So, but yeah, that's how it'll work. I'll if I can get it reset and everything and redone, I can show another video where we rebuild this and all the way through and bring up all the interfaces. But hopefully this has been somewhat helpful. Hopefully this has taken away some of the black box, thoughts about how SDA works and how DNA Center works, and it made you a little bit more comfortable about how it works and how to deploy it. Thanks for watching.